Okay, you had 3 to 36 every third on page 434. This is the first section in chapter 10. Now, obviously, you can't ask me questions as we go, but I'll point out as much as I can. So, just in case, if there's anything that comes up, then hopefully I'll have answered your question. But if you're not sure still, you can always come and ask me later. Okay, I'll be in tomorrow, and on yeah, we don't have algebra tomorrow, but you can definitely come in and ask if you need to. Okay, start with the first one. Number 3. Most times when people look at this, they are just going to cancel out the 4x and 4x. But the only thing you can cancel are factors. Yeah, so the 4 is a factor and the x is a factor. You cannot cancel here because these are parts of factors. But look, if you look at the top, they do have something in common. 4. That's fine. If I factor out a 4 from the first term, that leaves me with x. If I factor out a 4 from the second term, that's a minus 3. Still 4x on the bottom. Okay, so here's a factor, here's a factor, here's a factor. We can only cancel factors. The 4 and the 4. You cannot cancel parts of factors, so you cannot cancel the x's. There's nothing left to cancel. This is the entire factor. This is the entire factor. It's just x minus 3 over x. Okay, so some of you, I kind of noticed, you're doing the work sideways, and it's okay. I tend to go downwards, partly because when we get to the equation solving part, it makes more sense. And also, there's no need to write equals. The assumption is whatever you have here is going to be equal to the next line. If you make it simpler, it's going to be equal to the next line. Okay? You do not want to do anything to the first line of the problem. Yeah, it stays that way. The next line is what you did to the first line to get it to be the same. So whatever you have here, don't touch it. Okay. There are some people I notice also. They said, "Oh yeah, we have a 4 in common, so we're gonna factor out a 4." If you did this, you're not factoring out a 4. What you're saying is, I'm going to multiply the numerator by 4. You cannot do that unless you multiply the denominator by 4. Yeah? This is not factoring. You're multiplying into the problem. You don't want to do this. Okay? You start here. If I factor out a 4, automatically you go to the next line. Factor out the 4, and then you write down what's left. The bottom, 4 and x. Okay? This right here is what you should have as your solution. Okay? That's the simplest form of what we started with. Questions for number 3? Not that I can answer, but just keep that in mind. Let's go on to number 6. Sorry. Okay, number 6. Okay, same thing. You look. Is there any way we can factor the numerator? Is there any way we can factor the denominator? Right now, there are no factors. On the top, do they have anything in common? A 2. 2 is not the only thing, though. They have a y in common. So, if I factor out a 2y, this becomes a 2. If you factor out a y, there's still a y left over. If I factor out a 2y from the second term, it's not going to be 0. There's got to be something there. So 1. Okay, we're going to do the same thing to the denominator. What do they have in common? Do nothing here. They have a 5. They also have a y in common. You do it on the second line. If you factor out a 5y from the first term, there's something left. Y. If you factor out a 5y from the second term, yeah, it's still minus 1. Now, we start to cancel the factors. 2 is a factor, y is a factor, this whole parentheses is a factor. 5 is a factor, y is a factor, y minus 1 is a factor. We can only cancel factors. The y's cancel. Some of you are thinking I can cancel out the y minus 1, but again, you cannot cancel parts of the factor. If you cancel out y minus 1 here, you're leaving a 2 behind. The entire factor is 2y minus 1. There's nothing left to cancel. Our answer is 2 parentheses 2y minus 1 over 5 parentheses y minus 1. Questions for number 6. Just keep it in mind, write it down if you're not sure, and then you can ask me tomorrow. Okay. Wait, anybody need that? Okay. This one, automatically, I know already, there are people that are going to just cancel right away. D and D, that gives me a D left over 7 and 49. There's a negative 7 on the bottom. So on top you have a 1 and then D minus 7. Which oddly enough is the correct answer, but it wouldn't have worked in any of the problems previous. You cannot cancel unless you have factors. Yeah, so we are going to work our way there. 1 over D minus 7 is correct. We need to factor first. So on the top, it's already factors, just D plus 7. There's not even factors. There's two things that are being added together. On the bottom, they have nothing in common, but we can go two sets of parentheses. Yeah, it's a two terms, it's a minus, they're both squares. First terms have to multiply to D squared. D and D, good. Last terms multiply to the last term. It's a 49. 7 and 7, that's good. We need signs to make it a negative 49. Signs have to be different. Plus minus, that's fine. Okay, now we have factors. You have a D plus 7, D plus 7, D minus 7. The D plus 7's cancel. Now, looking at this, there are some of you that have done this correctly, but you would say your answer is D minus 7. You got to remember D minus 7 is on the bottom. There's got to be something on the top. 1. Good. This is the correct answer. If you just started canceling without regard, you would have came out with this answer. I wouldn't have given you full credit on the quiz though. Yeah. Right answer, wrong process. Minus 2. Question. Okay. Can we go on? Okay, wait. Hold on. This is a minus. My fault. Okay. We are going to factor first. There's nothing you can cancel. Yeah, you cancel first thing, you would have had minus 3 right away. Okay, so starting on the top, in the numerator. First type of factoring, do they have anything in common? A 2. If you factor out a 2 from the first term, that leaves me with t squared. From the second term, 3t. From the third term is plus 2. Okay? We do it to the bottom. Do they have anything in common? A 4. If I factor out the 4, now there are some people who think, oh, I can factor out and I just go straight to the 2 parentheses. You don't want to do that, it's confusing. Go little at a time. Factor out the 4, write down what's left. T squared minus 3t minus 4. You're just taking each one, factoring out a 4. Now, we have factors, the 2 in the parentheses, the 4 in the parentheses. We can cancel out the 2 and the 4, that becomes, yeah, half, 1 over 2. We cannot cancel anything here because we cannot cancel parts of factors. Yeah, these are parts. You cannot cancel the t squared. You cannot cancel the 3t. We need to factor this further. So, we'll do it again. This parentheses can be factored into 2 sets. The 1 is still in the front. First terms multiply out to t squared. T and t. Last terms multiply out to positive 2. 2 and 1, that's good. We need signs to make it a positive 2. So that means that the signs have to be either plus plus or minus minus. Notice, this is 2t. On the ends is 1t. 2t and 1t is 3t. That gives us our middle term. Okay, we do the same thing to the bottom. The 2 is still there. We take the parentheses. We factor into 2 sets. First terms multiply to t squared. Last terms multiply to negative 4. So let's see. We'll go 4 and 1. That's fine. We need signs to make it a negative. It's either, the signs got to be different. It's either plus minus or minus plus. We need a negative 3t in the middle. So, should be minus 4 then. Okay. And a plus 1. Yeah, this is a negative 4t. On the ends is a positive 1t. Okay, now we have factor, 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 factor. We need to cancel factors. T plus 1. Anything else? Again, you cannot cancel the t's because that's part of the factor, same with the 2 and the 4. So, what's left? We have a t plus 2 on the top, and a 2 parentheses t minus 4 in the bottom. Okay. Okay, switch. Number 15. You need to factor first. This is going to be a common mistake. There are a bunch of you that think that we can factor the top. Some of you are saying it's already simplified. Some of you don't know why, but you're saying it's simplified. Okay, so some of you are saying, okay, we can actually factor the top. So let's try. Okay, hold on. Okay, how do you factor the top? There's nothing in common, right? Okay, so you went 2 parentheses. The first terms you put, okay, x and x. Last terms had to be positive 1, so you went plus 1 and plus 1. And then the bottom is x plus 1, and then you cancel. Okay, seems to make sense. Only one problem. Oops, sorry. Okay, if I factor the top into x plus 1 and x plus 1, if I do the distribution, this is x squared, 1x. If I distribute the 1, plus 1x, plus 1. If I combine the terms, x squared plus 2x plus 1. See, this is not the same factoring. Yeah, it doesn't give you x squared plus 1. This right here gives you x squared plus 2x plus 1. We're trying to factor this. So, this is not the correct factoring. Since it's not the correct factoring, we cannot use it. There is no way, and hopefully you're starting to remember this now, you cannot factor 2 terms with its plus, yeah, unless they have something in common. They have nothing in common, in which case, it's already simplified. Ooh. Sorry. I don't think we named this yet, but we can just go with already simplified. If you guys think of a better name, just make sure you remind me. 18. First step, factor. Good. Do they have something in common on the top? Right here in the numerator, they have an 8. So I factor out an 8. That leaves me with y squared and a minus 4. On the bottom, you factor out a 4, okay? If you factor out a 4 from the first term, that's a y squared minus 4. Okay. Oh, perfect. Y squared minus 4 cancels. That leaves me 8 over 4, which simplifies to 2. Okay. Now, for those of you wondering, we do not want to put this in set notation because we're not solving for the variable. This is the simplest form of what we started with. Yeah, so it's not, there's no set here. We are not writing it in set notation. It's only when we are solving for the variable. That's what set notation is for. The set of all solutions, yeah, that solve the problem. We're not solving a problem, we're simplifying an expression. Okay, so 2 is the simplest form of what we started with. No set notation. You'll know when we have set notation. It's when we actually have an equal sign in the problem. There's no equal sign, so we just simplify. 21. By now, hopefully you realize we cannot do any canceling. There are no factors yet. So, first type of factoring, look at the top. Do they have anything in common? No. 2 sets of parentheses. First terms, b and b. Good. Last terms, means a 21. 3 and 7. Signs have to be the same. It's a positive 21. It's either plus plus or minus minus. Good. Minus minus because we need a negative 10. This is a negative 3b. On the ends, it's a negative 7b. We'll do the same to the bottom. Nothing in common. First terms. We need a 28. Okay. The signs have to give us a positive 28. So it's got to be the same. We need a negative 11 in the middle, so it's minus minus. Okay, we have the factors. Now we start canceling factors. You cannot cancel the b's because it's part of the factor. So, b minus 3 over b minus 4. This is the simplest form of what we started with. hope you folks are getting the hang of this. Is this okay? Questions? No, not questions. Okay, let's go on. Can I switch? Looking at the top. Good, it's a minus. Yeah, so two terms, they have nothing in common, but we can go with two sets of parentheses because it's minus. Just so long there's no middle term. T and t gives me the first term, t squared. We need a negative 4. Now there are two ways to do it. It's either 4, 1 or 2, 2, but since we don't want a middle term, it's got to be 2 and 2. Okay, on the bottom, the exponent tells us to write the base twice. So we're going to write t plus 2 and t plus 2. Okay, it's totally factored. Now we start canceling factors. We can't cancel the t's. It's just t minus 2 over t plus 2. Okay. I'm going to switch. Okay. Now, this one is a little bit on the tricky side. 6 minus y cannot be factored. We just leave it. There's nothing in common. You can't go two sets of parentheses because there's no square in the term. On the bottom, you have y squared minus 2y minus 24. Nothing in common. We'll go two sets of parentheses. Let's see. This is y and y. That gives me y squared. We need 24. Two numbers that multiply to 24. Keep in mind, we need a negative 2y in the middle. 6 and 4. That's fine. We need signs to make it a negative 24. That means they have to be different signs. It can't be the same because that would make it a positive 24. So, it's either minus plus or plus minus. Negative 6 and a positive 4. Keep in mind, this is a negative 6y. That's a positive 4y. Negative 6, positive 4. That'll give us negative 2y in the middle. Okay, so far so good. Thing is, we cannot cancel factors. Although, this right here and this right here kind of look the same. Here's how we fix that. I'm going to multiply the top by negative 1. Okay, now, you cannot just multiply the top without multiplying the bottom. So I'm going to multiply the bottom by negative 1. Okay? Multiplying the top by itself by a negative 1 changes the entire fraction altogether. It's kind of like 2/4. If I multiply the top by negative 1, it becomes a negative 2/4. It's a totally different fraction from what we started with. Yeah, if you multiply the top by negative 1, you gotta multiply the bottom by negative 1. Okay, so here's what happens. Let me erase. If I multiply the top and bottom by negative 1, I'm going to take the negative 1 on the top and just distribute to the top. Ignore the bottom for now. If I distribute to the top, it'll be a negative 6 and a positive y. You still have negative 1 on the bottom, y minus 6, and then the y plus 4. Notice, now the top and the bottom match. You can cross off. You can cancel the factors. In which case, you have 1 over negative parentheses y plus 4. If you want, you can move the negative to the top, negative 1 over y plus 4. Either way is fine, but these are your solutions. One of them is okay. Number 30. The idea for 30 is the same. The base, you write it twice. That's what the exponent tells us. The denominator, you can factor into two sets of parentheses. B and B, you need a negative a squared. Plus minus. Okay, notice this b minus a is kind of like stuff on the top. So, here's what we're going to do then. We're going to multiply top and bottom by negative 1. Whatever you do to the bottom, you got to do to the top. So we're going to multiply top and bottom by negative 1. If I distribute this negative 1, we'll still have b plus a in the first parentheses. This will change it. Negative 1 times b is negative b. Negative 1 times negative a is a positive a. You still have the top is the same. all I did was distribute the negative 1 to both these terms. The top didn't change. Notice the a minus b's are the same. I can cancel one of them. That leaves me with, wait, let me shrink this up. Okay, so now that it's canceled, that leaves me with a negative 1 parentheses a minus b over b plus a. To make this simpler, we'll just distribute the negative 1. So that'll give me negative a plus b over b plus a. If you want to write in order b minus a over b plus a. Any of these are acceptable. Yeah, either this one or this one. Can I switch? Yeah? Okay. Okay, let's see if you can do this now. Factor the top, factor the bottom. Do they have anything in common? If not, we go 2 sets of parentheses. The top, nothing in common. M squared, that gives me m to the 4th. N squared. We need a negative n to the 4th, so we need the signs to be different. Good, so that's plus and minus. Let's see, on the bottom, they have a 4 in common. If I factor out the 4, the first term, there's still an m squared left, and an n squared left. Oh, m squared and n, yeah, those cancel. This can still be factored, so we'll just factor that. 2 sets. M and m gives me m squared. I need n squared at the n. N and n. I need it to be a negative n squared. Okay. Some of you look in the back of the book, and I think it'll say m squared minus n squared over 4. All your answers should be in the most factored form you can. Simplest factored form. This is what we're looking for. The only way to know whether or not you can cancel is to have it completely factored. So it has to be totally factored. Okay, one more. Idea is the same. Factor everything. There's nothing that can be canceled at this point. Start with here. Nothing in common, so we'll go 2 sets. X plus y minus y. Okay, that's fine. Let's see. This has nothing in common. We'll go 2 sets again. First terms, x and x gives me x squared. We need a positive y at the end, y squared. Y and y. Okay, we need the signs to be the same because it's a positive y squared. So minus minus. We need 2xy. This is a 1xy. On the n is 1xy. That'll give me 2xy in the middle. Okay. This exponent tells me to write the base twice. X minus y, x minus y. It's okay? We're going to factor this part. Nothing in common. First terms multiply out to the first term. X and x. We need a negative 5y squared. So we know it's y and y. Negative 5, that's like 5 and 1. Okay, we need the signs. We need the signs to make it a negative 5y squared. So if you want it to be negative, they have to be different. Let's see. Either plus minus or minus plus. Okay, minus plus. Okay, we have it totally factored. Now we start canceling stuff. X minus y's cancel. X minus y's cancel. X plus y's cancel. And there's nothing left. X minus y is left on the top. X minus 5y is on the bottom. Okay. Okay, hold on to the sheets. When we have our first quiz, now it's going to be on Friday instead of Thursday. You can turn all 3 sections in one time. Okay? And then you can still ask me questions about it tomorrow or whenever you come in. Okay? Let's go on. Here. Copy this down. Need more time? If you need more time, have the substitute pause, and then as soon as you're ready, start the video up, continue, yeah, start it back up, and then we can go on. Okay, now that you have this written down, the idea is to make the answer as simple as possible. The goal is to multiply the two fractions together. But it's so much easier to just cancel as opposed to multiplying them together and then canceling. So here, the easiest way to do this. This is 4a to the 4th times 6. On the bottom is 3 times 15, no, sorry, 5a squared. Okay, temptation is to multiply them together. We have everything factored now. Just as, yeah, here's a factor, here's a factor, here's a factor, here's a factor. Okay, so we are going to cancel factors. Okay, so look, are there any factors we can cancel? The 3 and the 6, this becomes 1, this becomes 2. Anything else we can cancel? Now, don't look at it as 4a to the 4th. You look at it as 4 separately, you look at it as a to the 4th separately. Here's a 5 and a to the 2nd. So, we can cancel the a's. If I cancel, there are leftover a's on the top. Good. A to the 2nd. Okay. Anything else you see that we can cancel? No. Now that we have it canceled, we can start multiplying out the numbers and we can leave the letters alone. So let's see. 4 times 2 is 8. There's an a squared left on the top. On the bottom, 1 times 5 is 5. There's no variables left. This right here would be the simplest form of what we started with. The goal is to multiply, but really we want to simplify. Let's try this again. Okay, switch. Okay, copy. Ready? Okay. The easiest thing to do is just write it as one big one. X plus 3, 5 parentheses, x plus 2, 5, and x plus 4. If you think you can work with everything up here without having to write it as one big fraction, that's fine. Okay, but really that's what you're doing. You're trying to multiply the fractions together. So now it's one big fraction. Now we just start our cancel. The 5's cancel. And that's it. X plus 3, x plus 2 over x plus 4. This would be the simplest form of what we started with. And really, if you think about it, if you just understand that you can only cancel factors, we could have done it here. There's nothing left. We could have gone straight from there to here. Okay, but for those of you that are getting confused with canceling factors, I would suggest writing it as one big fraction with all the factors in parentheses and start canceling factors. Okay, let's try it again. Obviously, there's not very much to cancel here, but we should factor everything first. Negative 3 times 4 on the top. Oh, this can be factored. They have a 2 in common. If you factor out the 2, that's 2m plus 1. You still have this, 2m minus 1. Okay, so everything is now factored. We can cancel 2 and 4. This becomes a 1, this becomes 2. Anything else we can cancel? No, there's nothing else. This 2 cannot cancel anything here on the bottom because you cannot cancel parts of factors. So on the top, we can multiply the numbers. Negative 6 over 2m plus 1, 2m minus 1. Is that okay? It's not so obvious. You couldn't have just gone from here straight down to here. Yeah, because we couldn't cancel anything. You cannot just look here and say, oh, I can cancel stuff. Yeah, because they don't match. But if I have everything factored, I can cancel out the common factors. Okay. Let's try a couple more. I would suggest writing it as one big. Negative 2 times n. This 7n plus 7 can be factored. 7 parentheses, they had 7 in common. That leaves me with an n plus, if I factor out a 7 from the last term, right here, 1. On the bottom, you still have 7 parentheses n plus 2. And then you have the other one, which is n plus 1. Okay, now we start our cancel. The 7's cancel. The n plus 1's cancel. Anything else? Good. You're not supposed to cancel this n because it's part of the factor. Negative 2n over n plus 2. That would be the simplest form of what we started with. Again, it's not obvious. You cannot just cancel here. You cannot just do the 7 and n. Yeah, you cannot do that. You need to factor and cancel common factors. Question, which I cannot answer. Here, we'll go on to. Okay, 2 more. Try. Ready? Okay, let's see. I'm going to write this as one big fraction. A minus 5, a plus 1. Nothing you can do there. A squared plus 1. Some of you are tempted to factor that, but you can't because it's 2 terms, it's plus. No middle term, it's not possible. A squared plus 1. This, on the other hand, is possible. 2 sets of terms. We can get a negative 1 at the end. We need a negative 1. Plus 1 minus 1. Okay, that's fine. Now we start to cancel. A plus 1's cancel. Anything else? A minus 5 is left on the top. A squared plus 1. A minus 1 on the bottom. Okay, last one. And then I'll give you put up the homework. Okay, factor, cancel, simplify. Ready? Okay. Let's see. I'm going to do this the long way. I'm going to write them as separate. Starting with the first one, it can be factored right up here. They have a 6 in common. If I factor out a 6 from the first term, If I factor out a 6 from the second term, it's plus 2. 15a is already factored, times 15 times a. On the bottom is a 5. Here, do they have anything in common? The 7. If I factor out a 7 from the first term is a. If I factor a 7 from the second term. Okay, now we start the cancel. A plus 2 is cancel. 5 and 15, that's fine. This is a 1. This becomes 3. Anything else? Nothing, yeah? There's nothing left to cancel. The 6 and the 7, the 3 and the 7. 6 and 3, you cannot cancel. It has to be top and bottom. Okay, so we just multiply now. Multiply the numbers on the top. 6 times 3 is 18, and there's an a left. On the bottom is 7. This is the simplest form of what we started with. Is that okay? This is what you're trying to do tonight. You're taking 2 fractions, multiplying, and really you're just factoring and canceling again. It's just like 10-1. Okay? So, here's your homework then. Page 437. Okay? If you folks have any questions, just come on in tomorrow. I mean, I know we don't have algebra, but I'm here at recess and lunch. And then let me know. We can do problems up on the board. Okay? Make sure now you have a quiz coming up on Friday. Yeah? 10-1, 10-2, and 10-3. Everything that you see here. Okay? See you there, folks. No, don't go. You can, if we have time, work on these right now. Yeah, you can help each other with it. Okay? I'm going. Okay.